Hey everyone, today we are talking about uniform speed versus average speed. So to review, speed is the distance you traveled divided by the time it takes you to travel that distance. So for example, 15 miles per hour would mean that in 1 hour you travel 15 miles. Now, when we're talking about uniform speed and average speed, we want to actually know what that speed means in that situation. So, for example, when we look at the world's fastest land animal, which is the cheetah, it can run 600 meters in just 20 seconds, which is super fast. Now, if you want to know how far it can run in 1 second, then you are talking about the average speed. And you are trying to figure out its rate by dividing 600 meters by 20 seconds. When you divide that, you figure out it's 30 meters per second. So on average, it can in 1 second run 30 meters, which is super fast. Now, do you think that this cheetah is maintaining its speed of 30 miles per second for every second? Like it's like a robot and it's constantly running 30 miles per second? Probably not, right? Because it's a living thing. It gets tired every once in a while. It's going to slow down once in a while. It's going to speed up once in a while. So if the speed is unchanged during a period of time, it's called uniform speed or constant speed. And that is a term you're going to want to add into your notebook. Uniform speed or constant speed is when it's unchanged. It's just constant the entire time. And usually, when we're talking about a living thing or a person, it's going to be really hard for that person or that animal to go at a constant speed, a uniform speed, and not change because it's going to get tired. However, if you're talking about a machine or a car, then it is more likely it's going to go at uniform speed or constant speed. So that's why when we talk about average speed, it's most likely what's happening. Because even when you're driving a car, you're going to slow down at a light or you're just going to slow down at a curve in the road. Okay, so uniform speed is when it's unchanged. So when a cheetah runs at a uniform speed of 30 miles per second, for 40 seconds, then it would run a total of 1,200 meters. But like we said, in real life situations, it's really hard to maintain a uniform speed. So it's more realistic to assume that the cheetah is running at an average speed. Okay, so average speed, we would then take the total distance covered at the very end and divide that by the total time that they took. So whether they stopped in the middle or slowed down in the middle or sped up, doesn't matter. For average speed, we're taking the total at the end for both distance and time and then dividing by it. Okay? So that's how we kind of figure out average speed. So this should go into your notebook. That average speed at the end, you're taking the totals for both. So for the cheetah's speed, at any minute could be higher or lower than its average speed, but it's kind of hovering near the average speed. Okay, on average, it can be running the average speed. Let's take a look at some examples so that it makes more sense for you. This is example 11 from your book. The average speed of a car for the first 2 hours of its journey is 60 miles per hour. Its average speed for the next 3 hours is 70 miles per hour. Find the average speed for the whole journey. So this is a perfect example where maybe this car is going on a road trip, a 5-hour road trip, 5-ish hour road trip, and it's kind of cruising along for the first 2 hours, going 60 miles per hour. And then afterwards, the person is like, oh my gosh, I need to hurry it up. Like, I don't have that much time left over. So then for the rest of the journey, they're driving at 70 miles per hour to kind of make up for the slow speed in the beginning. Okay, so I'm actually going to make myself a table to kind of organize my work here because we know from before that to find the average speed, we need to basically divide our total distance by our total time. And I have, two different legs of this journey going on. So let me just graph this out. So let's do hours versus distance. Okay. So we know it took 5 hours. 1, 2, 3, 4, 5. All right. Now let's reread the problem. The average speed of a car for the first 2 hours of its journey is 60 miles per hour. So if they're traveling 60 miles per 1 hour, that means after 1 hour, they traveled 60 miles. Okay? This distance is in miles. After 2 hours, because for the first 2 hours they're traveling 60 miles per hour, they're traveling another 60 miles because it's 60 miles per hour. Its average speed for the next 3 hours is 70 miles per hour. So for these next 3 hours, it's 70 miles for every hour. Okay? So to find the average speed, we need the total distance divided by the total time. Okay, so the total distance would be 60 plus 60 plus 70 plus 70 plus 70. Those are all miles. Divided by the time. Well, the time was 5 hours. Okay? So let's see. 60 plus 60 is 120 for the first 2 hours, plus 70 plus 70 plus 70. So in total, 330 miles per 5 hours. That means I have to divide. So 330 divided by 5 is 66. So the average speed was 66 miles per hour. That makes sense because for the first 2 hours, they're traveling 60 miles per hour. And then after that, the next 3 hours, they're traveling 70 miles per hour. So, of course, the average is going to be somewhere between 60 and 70, and probably a little closer than 70 compared to 60 because they traveled 70 miles per hour for 3 hours as opposed to the 60 miles per hour for 2 hours. Okay, so that's how you figure out the average speed. You need to figure out the total distance that the person traveled divided by the total time. So because this person was going at 2 different speeds, then you're going to have different distances that you need to add up. Okay, let's try another example. Towns P and Q are 30 kilometers apart. William cycles at an average speed of 15 kilometers per hour from P to Q and return from Q to P at an average speed of 12 kilometers per hour. Find his average speed for the whole journey. Okay, go ahead and pause the video and try it on your own first. All right, for me, I'm going to want to draw town P to Q. They are 30 kilometers apart. And remember, my average speed is total distance divided by total time. Okay, so William is going from P to Q and then returning from Q to P. So his total distance would be 30 kilometers plus another 30 kilometers, right? Because he's going from P to Q one way, 30 kilometers, and then he's coming back again, so that's another 30 kilometers. So it's twice, 30 kilometers twice. So it'd be 60 kilometers. Okay, now we got to figure out the time. That distance was pretty easy. William cycles at an average speed of 15 kilometers per hour from P to Q. Okay, so if he's going 15 kilometers, let me do this hours versus kilometers table. just helps me organize my thoughts. Go up to 4 for now. Let's see, 15 kilometers per hour. So 15 after the first hour, and then 15 after the second hour. 15 plus 15 is 30. So he already made it after 2 hours. Okay. That's from P to Q. 15 plus 15, the 30 kilometers. Took him 2 hours. Then back from Q to P, he's going 12 kilometers per hour. So we got 12, another 12. That's 24, not quite the 30. And then plus another 12 for the 5th hour. That would be 36, right? So up to here would be 36. So what would it be at 4.5 hours then? 4.5 hours would be another 6 kilometers, right? Oh, that might do it. 12 plus 12 plus 6. That's 30. That's halfway, right? Because each time he's going 12 kilometers per hour, so then halfway would only be 6. So we just have 4.5 total. And that would get us back to P. So in total, looks like William traveled 4.5 hours. Okay, and that's using my table. You could solve for that in any way that you find fit. Okay, so we have really 60 kilometers divided by 4.5 hours. So 60 divided by 4.5. Ugh, that's going to be a fraction. So that's, let's see, 13.3333. We know the repeating decimal is 0.333 is 1/3. So that's 13.1/3 kilometers per hour. kmph. Okay, so his average speed was 13.1/3 kilometers per hour. That makes sense because he was going really fast on the way there, 15 kilometers per hour, and then on the way back a little slower, 12 kilometers per hour. So 13.1/3 is kind of between 12 and 15.